Okay, we are studying topic steady state analysis. Last class, I explained some of the problems. Still some more problems are there. Let me explain. So once again, these problems already asked in different competitive examination. So this is one problem. Find VAB average. Find VAB average. So here one AC source with the frequency of 5000, one DC source. And resistor is there, inductor, capacitor, another resistor. Voltage across capacitor is VAB, but is asking VAB average value. So this circuit comes under sixth case. When network contain sources with different frequencies, should use only superposition principle to find the voltage, current, but not voltage, current, and power. So here is asking VAB, but VAB average. So find VAB with DC first, then VAB because of AC. So VAB will contain two terms, DC response plus AC response. But DC plus AC average is equal to DC only, na? This earlier I explained. If f of t contains some A0 plus A1 sin omega t. So DC plus AC. What is f of t average? Is A0 only. So whatever may be the value of A1 or omega, this is not coming here. So it is meaningless to find this response. If you just find DC, that itself will become the average. So time saving technique is find VAB because of DC only, because he's asking average. So with the DC, this AC voltage is, this AC voltage not there. So the source not there. And resistor is there. For DC, capacitor is open. And for DC, inductor is short. And this resistor as it is. And there is a DC voltage of 5 volts. This is 2 kilo ohm. This is 1 kilo ohm. And capacitor open, inductor short. So what is the voltage across this capacitor? What is VAB? So capacitor charged to voltage of 5 volts only in the steady state. So VAB is equal to 5. So with DC, VAB is 5. And what is VAB average? 5 only. So VAB average is the question. If he is asking VAB, DC plus AC, both you have to find. So VAB answer given, but VAB question is only average. Na? So that is equal to 5. 5 is the answer. But if question is find VAB, compulsorily with AC response also we have to find. So AC response means capacitive reactance, inductive reactance, then use voltage division. So XC is done, minus J by omega C, XL is done. Then here this side positive, this side negative, but VAB polarity reverse. Na? So therefore minus 5 pi of 0 into capacitive reactance by total reactance, complex form, convert into phasor, this phasor change into trigonometric. This is VA. Okay, so this is what VAB average. Sometimes they ask VAB RMS. If they ask VAB RMS, square root of 5 square plus 0.078 square by 2. So this is the answer. Or they may ask form factor or peak factor. Accordingly, use formula and substitute. This is the problem. Next problem is almost similar, but question is find steady state current in RMS. So previous problem average, now we are asking RMS. But this again contain AC plus DC. Because he is asking RMS, so AC response we have to find, DC response also we have to find. So finally we have to find this current I of t. This contain two parts, IDC plus IES. So using superposition theorem, DC current. So if it is only 8 volts there, inductor is short. AC voltage source short, 8 by 1. So 8 by 1 is 8 amps. With the AC, 12 sin theta, what is the phasor form? 12 of 0 by 1 plus, what is inductive reactance? J, omega is 1, L value is also 1. So it is J ohm. So simply 1 plus J. Using calculator, simplify. This is in phasor form. But remember, don't do this kind of mistakes. 12 is what? What is this 12 is? Maximum. And here I have written 12 of 0. So that means this 12 is also in maximum. What is this value? Ultimately, end result is also in maximum. And when you convert into trigonometric function, what is needed here? Maximum only. Okay. So I am saving time. Otherwise, here 12 by root 2, then end answer is in RMS. Again multiply with root 2, you will get the maximum. Answer is same only. Just to save the time, that smart work, you can do it. And question is to find RMS. So root of 8 square plus 12 by root 2 square by 2. So maximum square by 2. This 10 is the answer. So just the sixth step in steady state analysis, what I told in the theory is very, very important. So many questions on sixth step. This is not asked in any exam, but I like this problem, so I am solving. I have taken in one of the book, or I don't remember. So x of t is given 2 e power minus t. This x of t. And y of t is nothing but x of 2t. What is the input applied to this network? Y of t. But what is y of t? X of 2t. This is x of t. X of t given, x of 2t is applied as the input to the circuit, and we want to find y of t, the g of t. So this is g of t. So g of t is the question. We have to do it. Find the g of t. So here network is given. What is the standard thing? H of s. So what is H of s? 1 by s by 1 plus 1 by s using voltage division. 1 by s plus 1 is the transfer function. Then inverse of this is h of t e power minus t. Any LTI system, How to find g of t? So g of t is always nothing but this output g of t is always nothing but input is y of t convolved with h of t. H of t is impulse response, y of t is input. By doing this graphical convolution, you can find out g of t. This convolution you will study in signal chain system. I am not explaining what is convolution, all those things. So that application directly I am explaining. If you understand, fine. Otherwise, after signal chain system, after convolution, go through this, you will understand. So h of s is 1 by s plus 1. Inverse of that is this. Then y of t. What is y of t? X of 2t. Na? What is x of t given? 2 e power minus 2t. So y of t is equal to 2 e power minus, in place of t, 2t. So this is what y of t. Now g of t is nothing but this is h of t, this is y of t convolution, graphical convolution. So one convolution, the theory part already, if you know it easily, these steps you will understand. It is like f3 of t is equal to f1t star f2t. So mathematically this is equal to f1 tau f2 t minus tau d tau. In general, limits are from minus infinite to infinite in general. So here f1 tau. So one function, change the variable. So 2 e power minus 2t change to 2 e power minus 2 tau. T becoming tau. So this function is like f1 tau. What is other function? f2 t minus tau. So this function change it to tau replaced with t minus tau. So that means what? Fold, then shift. So after folding, now shifting. So both the functions are overlapping from 0 to t. That's why you have to integrate from 0 to t. 0 to t, what is f1 tau? 2 e power minus 2 tau. Then f2 t minus tau e power minus t minus tau d tau. Integrate with respect to tau. Tau is the dummy variable. And detail, just to go through it, you will get this answer. Okay. So this convolution application I am using, signal chain system, definitely you will do lot of work on this convolution. Convolution concept is important for any engineering student. Control system you apply, networks you apply, signal chain system, digital signal processing, communication, image processing, so many subjects you will come across convolution. Convolution is important, useful concept. This is another problem. The step response of an LTI system is S of t equal to e power minus 2t. So system given, step is given, response e power minus 2t u of t is the step response. So when you apply step, system giving response. That is what this. That is a given data. The steady state response of the system for the input. So with this input, this is the output. With this input, what is the output? That's what is asked. So this problem can be solved in two ways. One easy method, already I solved one general purpose problem. With the help of step response, find the transfer function. This is easy method. What is a transfer function? Ratio of Laplace transform of output by input. What is the output is e power minus 2t. What is Laplace of this? 1 by s plus 2. What is Laplace of U of t? 1 by s. So s by s plus 2 is what? H of s. One system function h of s is known when some AC signal applied as a input. How do you find output now? H of s at s equal to j omega. What is omega? Omega is 2. So replace s with j2 and simplify. 1 by root 2 angle 45 will come. That you change into trigonometric form. So what is asking? Steady state response of the system for the input. So this system is giving, is a minor mistake. Yeah, no mistake. Input is having minus 45 degrees and system is giving plus 45. Minus 45 plus 45 0 and input signal amplitude is 2. The 2 is multiplied with 1 by root 2. So you will get to root 2 sine 2t. So this step is nothing but input is 2 into 1 by root 2. Function is sine 2t minus 45. Already plus 45 got it. So this simplify, you get this. Is the answer. So in one way it is a simple model only, but a different style they ask, you have to correlate to that model and solve. There is other way of doing. This is lengthy, but this concept also you should know it. Step response given. What is impulse response? Impulse response is nothing but derivative of step response. So e power minus 2t u of t differentiate. Here one important, very important point is don't forget to write u of t. Don't forget to write u of t. When u of t is there, function is a causal signal existing only for t greater than 0. Now u into v method you have to differentiate. If you don't take u of t, normally only one function you take and differentiate, and answer is going to be wrong. So 2 e power minus 2t, derivative of u of t is a delta of t plus u of t, then the differentiation of this minus 2 e power minus 2t. So this is impulse response. Impulse response h of t. So h of t, this you simplify, you are getting this. From h of t you can find h of s. Laplace of each. Now simplify, you are getting same. So this h of s answer, this h of s answer same. Then rest of the method is same. So this will save the time. Ratio of Laplace transform output by input state away give transfer function, that is better. Now V of t is two AC signals, 10 root 2 cos t plus 10 degrees plus 10 root 5 cos 2t. Here t, here 2t. These things you carefully have to observe. Now having different frequencies. E is applied to a series combination of resistance R equal to 1, inductance 1 Henry, inductance of 1 Henry. The resultant steady state current I of t is. So indirectly, network is given, AC source with different frequencies given, find the response I of t. Here in this circuit, what is input? V of t. What is the response? I of t. How do you get the transfer function? Transfer function is nothing but ratio of Laplace transform of output by input. What is output to I? What is input to V? So it is nothing but I by V you have to find. So 1 by R plus j omega L. So this R is already there. Inductive reactance is j omega L. So what is I by V? 1 by R plus j omega L. Now using superposition, as source is having different frequencies, H j omega. You can also switch into S domain just to straight away in omega. So H j omega 1 by j, sorry, 1 by 1 plus j omega 1. Omega 1 is 1 na? And L value is 1. So simplify, you are getting this. Then Hj omega 2, 1 by 1 plus j. Now omega is 2 into L value anyway 1. Simplify, you are getting this. So this is one transfer function. This is another transfer function. What is the output now? Current. Therefore, I of t is equal to, what is the input here? 10 root 2 na? So 10 root 2 multiplied with 1 by root 2 cos function t plus 10 degrees minus 45. Then second function is 10 root 5 by root 5 cos 2t plus 10 cos 2t plus 10 delayed with minus tan inverse 2. So just use it the superposition principle. I hope understand. Or if you really want in S domain, you are finding any difficulty, you can also do like this. This is R, this is SL. You call this is V of S. This is I of S. So V of S is equal to I of S into R plus SL. Na? Now what we want? I of S by V of S is nothing but 1 by R plus SL. This is what H of S. Now simplify. H of S at S equal to j omega 1. That is nothing but j. What is the first signal frequency? First signal frequency is 1. So this is 1. Therefore 1 by, what is R value? 1. S equal to j, omega is 1. L value is also 1. So 1 by 1 plus j only. Na? Same thing here. 1 by 1 plus j. So like that also you can do it. So you can do in omega domain or S domain. Both are same. But what is important to use superposition principle. That generalized problem is very, very important, that model. We are solving many problems based on that only. Now, the transfer function relating the input x of t to the output y of t of a system is given by g of s equal to 1 by s plus 3. So g of s, purposefully they use different notations. Okay, the transfer function relating the input. Input is x of t, output is y of t, system given by g of s. So 1 by s plus 3. Therefore, y of s by x of s equal to 1 by s plus 3 given. The unit step input is applied to system at time t equal to 0. Assuming that y of 0 is 3, the value of y of t at time t equal to 1. The value of y of t at time t equal to 1 is. So this small smart work you have to do. Output by input is 1 by s plus 3. Now s plus 3 into y of s equal to s plus 3 into y of s equal to x of s. Okay. So s into y of s is nothing but dy by dt, na? Inverse of this. Dy by dt plus 3y is equal to x of t. If you apply Laplace, you will get this. Now again apply. This is the Laplace transform with initial conditions 0. with initial conditions 0. Now we got the differential equation. Now again apply Laplace transform. After Laplace transform, what you get? S into y of s minus y of 0 plus 3 y of s, y of t Laplace is y of s is equal to x of s. Now y of 0 given 3 na, that you substitute. Okay. So what is asking? Y of t is asking. So solve for y of s, because what is x of s? X of s is a unit step input is applied na. Unit step. What is Laplace of unit step? Is 1 by s. So 1 by s. So simplify y of s. So this y of s using partial fractions a by s plus b by s plus 3. Partial fractions we discussed earlier. Find ab, then inverse of each. You will get y of t. In this y of t is asking value of y of t at t equal to 1. Replace tb equal to 1. Further simplify, you will get this. So this is a reasonably good problem. Okay. So this is one model, good model. So this is one good model. So a system function given, we are getting a differential equation, again applying Laplace transform. Second time when I am applying Laplace, so initial value substituted, then y of s, inverse of that y of t, t with 1, you are getting the answer. This simple problem, in the given network V1 100 of 0, V2 100 of minus 120, V3 100 of 120, all polarities, this side positive, this side negative. The phasor current I, the phasor current I, this current I is asked. The phasor current I is. So simply use nodal equation, nodal analysis and solve for I. So some of the currents, you can write nodal here na. This current, so this is 0 voltage anyway, 0 voltage anyway. And what is the voltage here? Minus V2 plus V3. The voltage at this node. Wherever you want to know voltage, start there, go to ground na, following CGR KVL convention. Minus V2 plus V3. What is the voltage here? Minus V1 plus V3. Minus V1 plus V3. So this current is equal to, you can sum of the currents entering 0, then solve for I, whatever it is. So this is 0, this voltage also 0, this voltage also 0. What is this current? Is minus V2 plus V3 minus 0, or otherwise this current is entering, this current leaving. And take it like this. This current I direction given like this. This I is equal to this. This is equal to this plus this. This current. So this I is equal to sum of these two currents. That means 0 minus of minus V2 plus V3 by this one J. then this current 0 minus of minus V1 plus V3 by minus G, capacitor reactance minus G. So direct step I have written, it is a nodal equation. Sum of the currents entering equal to sum of the currents leaving. Based on that I have written equation, and V1, V2, V3 values already given in the problem. V1, V2, V3 already given. Substitute, simplify, you will get answer. But when you are simplifying, concept is simple, but you need to operate calci carefully, fastly, efficiently. Then only you will get correct answer. The gate problem. This is also a nodal application. Find V1. Find V1. So one AC source given, dependent AC voltage source 0.5 V1. V1 is here. So solution is find V1. First find out, is it single source problem or two source problem? Sources are two, but having same frequency, 10 power 4. Frequency is same. 0.5 V1. So this dependent source also AC. That frequency also same 10 power 4. So same frequency category. And XL is J omega L. J omega L. Want XL is J omega. Omega is 10 power 4. L value 50 into 10 power minus 3. So you get 500 J. So like that capacitor reactance, and here you write nodal. This current is entering, this current leaving, this current leaving. So 10 power minus 3 by root 2 angle 0 is equal to, and what is the voltage here? Some VA, some unknown. Here voltage is unknown. So VA by 1K downward current plus, what is this one? V1 by 500. Voltage across 500 is already V1. So V1 by 500. Okay. Then what is the voltage here? What is the voltage here? Minus 0.5 V1 minus 0.5 V1. Start here, go to ground. Minus V1 plus VA. VA means this is plus, so it is ground minus. So we are starting here, going to ground. It is equal to what? It is minus. Going from minus to plus now, minus 0.5 V1 minus V1 plus VA. So this is minus 1.5 V1 plus VA. So here you have to write one more equation. This current is entering, this current leaving, this current leaving. So second equation, what is the current entering? V1 by 500. V1 by 500 is entering, and voltage by 500 J plus voltage by minus 100 J. Two equations, two unknowns. Solve for V1. Okay, we'll get the answer. Use source transformation as the alternative method. Change this into voltage source. This current source change into voltage source. 500J minus 100J parallel, simplify. Then go for one mesh equation, solve for I, and V1 equal to 500 into I. Like that also you can solve. These two options. I think straight away nodal also you can apply. Another nodal application only. Problem looks easy. I1 given 3 cos omega t. I2 also given 4 sin omega t. I3, it's a straight away current law. Na? Using as per current law, as per KCL, using KCL, I1 is equal to I2 plus I3. These directions, everything given in the problem. He is asking I3. So I3 equal to I1 minus I2. What is I1? 3 cos omega t. But I2 is 4 sin omega t. Here carefully change sin into cos or cos into sin. So sin is the reference to generally, cos converted to sin. So what is I1? 3 of 90 minus I2 is 4 of angle 0. Now this is equivalent to 3 of 90 means 3j minus 4. So indirectly, what is the value? Minus 4 plus 3j. It is, I told you now earlier in the rules, minus x plus jx is nothing but what? X root 2, x root 2 or x square plus x square, 2x square. So x root 2 and angle will be plus or minus 180 and here minus now, so minus 40. Indirectly, problem is designed based on this application. So testing the student whether aware of this concept or not. So use that and simply will get the answer. This is also KVL application. V1 given, V2 given, V3 given is asking VR of t. So V1 is AC source, V2 another AC source, V3 another AC source is asking VR. So VR is nothing but started positive, go to negative. Started positive, go to negative. Directly write the expression for VR. So V3 of t, because this side is positive, this side is negative. Na? So positive to negative is plus V3 of t. Going from minus to plus, so minus V2 of t, positive to negative again plus V1. And each one replace with the phasor form. Take help of calculator. Simplify. You will get the answer. There is another question in this. F of t given, find f of s. F of t, one what do you call, one signal, one function f of t given, find its Laplace transform. So what is f of t is existing from 0 to 1. Its equation is t, but you have to write u of t minus u t minus 1. U of t minus u t minus 1. So t u of t minus t u t minus 1 is equal to t u of t minus, here how it is written, t u t minus 1. So t minus 1 plus 1, minus 1 plus 1. Same thing only now, ut minus 1. So t u of t minus t minus 1 is multiplied with ut minus 1 and minus and plus become minus ut minus 1. Now apply Laplace. What is Laplace of t? 1 by s square. Using time shifting property, e power minus s by s square and ut minus 1 transform is e power minus s by s. This is the answer. So signal f of t, how to find the Laplace. See, my sincere appeal, already I told earlier, don't leave any topic as a choice. Every topic reasonably depth you should prepare. Then only you can solve the problem. Qualifying in GATE may not be a tough job, but undoubtedly getting a good score is very, very difficult. To get a good score, really great. So here find V2 by V1. There is another circuit given. It's also easy. The figure shown an RLC circuit excited by a sinusoidal voltage of 100 cos 3t volts. So this AC given 100 cos 3t, where t is in seconds. The ratio of amplitudes of V2 by V1. V2 is across RC, V1 is across RL. It is asking ratio of amplitudes of V2 by V1 is. V2 by V1 is. Okay. So what is the impedance first? 4, resistance 4, inductive reactance J omega L. Omega is 3 na? So J3. And this resistance 5. Capacitor reactance 1 by J, omega 3. Capacitor value 1 by 36. Simplify 9 minus J9. For impedance you got it. What is the current? 100 of 0 by 9 minus J9. So this is the current. What is the voltage V1? Current into 4 plus J3 na? This inductive reactance is J3. 4 plus J3. Current into 4 plus J3 is V1. Current into 5 minus J12 is, this is minus J12. And V2 by V1 magnitude only is asking. I cancel. So 5 minus J12 by 4 plus J3 magnitude. This is the answer. If they're asking angle, numerator angle, denominator angle, simplify you. Another problem. The impedance of a parallel circuit is 10 minus J30 ohm at 1 megahertz. Impedance of a parallel circuit. The value of circuit elements will be. So impedance Z is given 10 minus J30. Parallel circuit convert into admittance Y. So Y admittance is nothing but 1 by Z. So that is 10 plus J30 by this one multiply, you will get 1000. Real part, imaginary separate. So this real is Y1, this is Y2. So Y1 is 1 by 100. That is G1. So G1 is 1 by 100. Resistance will be 100. 1 by 100 reciprocal is 100. Then Y2 is this. G2 is what? J3 by 100. But that is capacitor reactance, J omega C. Is a Ohm's form, na? Sorry, Mohs, J omega C. So J omega C equal to J omega is 3. No, this total value is J3 by 100. In this we know omega, solve for C. In this we know omega, solve for C. That's all. I hope it's clear. Here are multiple options given. This is asked in IES. So this one circuit, for what value of C capacitor I equal to 0? For what value of this capacitor current I is also given in the circuit. So this I is 0. So when current is 0, same voltage appear at other node. Same voltage appear at other node. That means whatever voltage is there here, same voltage will come here. This voltage is source already given, na, this one. The voltage here also same coming, then only this I is equal to 0. That means indirectly, what is the voltage here is same as this, na? That is 5 pi angle of 0. That is the voltage here. Now assume all currents are leaving, sum of the currents leaving equal to 0. 5 pi angle 0 by inductive reactance plus 5 pi angle 0 by inductive reactance and capacitive reactance. So in this, omega is known, solve for C. So rest of the part is just a simplification. Carefully simplify. A lot of steps are involved. Carefully solve for C. Generally, IES questions, more time is wasted to solve the problem. Gate questions, logically they ask the questions. So smartly you have to answer gate questions. This is an application of final value theorem. A ramp voltage V of t, 100 t U of t is applied to RC differentiating circuit. RC differentiating circuit with R equal to 5K, C equal to 4 microfarads. The maximum output voltage is. So intelligently used a word RC differentiating circuit. So it's an application of PDC, pulse and digital differentiator. So linear wave shaping, you come across differentiator and integrator. So differentiator, first capacitor will come, then resistor. Accordingly, you have to draw the circuit. An input of 100 t U of t applied is asking maximum output voltage. So what is the Laplace? Input Laplace Vi of s equal to Laplace of 100 t, 100 by s square, then h of s domain V naught of s by Vi of s, you are getting this. Output is nothing but h of s into Vi of s. So s by s plus 50 is h of s. Vi of s already 100 by s square. So V naught of s. But here asking maximum output voltage. So using final value theorem. What is final value theorem? If you recollect final value theorem, f of infinite is nothing but limit s tends to 0, s into f of s. So final value. So limit s tends to 0, s into here V naught of s. So substitute, simplify, you are getting 2 volts. So indirectly, we are using the final value theorem to find the maximum output voltage. Generally, when input is ramp to any differentiator, what is differentiation of ramp? So input is ramp applied like this. when you apply ramp to any differentiator, it will go and again some constant like this. So what is the final value of this? Final value is nothing but this only, na? So directly final value I am finding. So that itself maximum output. This itself maximum output, na? This is maximum. So intelligently asked maximum value. That maximum value is nothing but final value of the function. So final value I am finding using final value here. That is the trick. Why impulse response considered as a transfer function? Why not other responses? For finding transfer function, why only impulse response is considered? This is not a exam question. This is the one of the student asked a doubt. I have given a proof. Impulse response apply Laplace, you will get a transfer function. So what is the doubt? Why impulse response only using to find transfer function? Why not? So transfer function is the ratio of Laplace transform of response to excitation, keeping all initial conditions 0. So x of t is input to y of t output. Now this is the one differential equation. Then apply Laplace, take the ratio. This is h of s. Now if x of t is impulse function, input is a impulse. What is Laplace of impulse is 1. Then what is y of s? H of s into x of s. H of s and x of s is what? 1. Laplace 1. So y of s equal to h of s. Y of t equal to h of t. So what is the meaning here? Using impulse response, we find transfer function. So I want system function, just impulse response h of t, apply Laplace, you are getting h of s. So using impulse response, we can find a transfer function using Laplace transform. So that's a simple idea. Here y of s is equal to h of s. Y of s equal to h of s. So h of s is what? Laplace of h of t. That is right. So impulse response, if you know, apply Laplace, you are getting h of s. That's right. For the network shown in figure below, the frequency radians per second at which maximum phase lag occurs. Maximum phase lag. So you have to find the output to whatever angle is coming, maximum phase lag. So again go for the transfer function V naught of s by Vi of s. Here 1 plus 1 by s by 9 plus 1 plus 1 by s, simplify. Then here we are particular with the angle. So angle of tan inverse omega minus angle of tan inverse 10 omega. Then theta omega is tan inverse omega minus tan inverse 10 omega. Maximum, for maximum differentiation should be 0. So d theta omega by d omega, tan inverse omega differentiation is 1 by 1 plus omega square minus tan inverse 10 omega is 10 by 1 plus this is square, 100 omega square equal to 0, and solve carefully, you are getting omega 0.316 radians per second. At what frequency maximum phase lag is occurring? At 0.316 radians per second, at this frequency, maximum phase lag is occurring. What is that maximum phase? Replace omega with this value, find out that is the maximum phase. Gate 16 ask for triple E. So phasor form application. In a series RC circuit, the value of R is 10 ohm and C is 25 nanofarad. A sinusoidal voltage of 50 megahertz, is applied, and the maximum voltage maximum voltage across the capacitance is 2.5 volts. Maximum voltage across capacitance is 2.5 volts. The maximum voltage across the series combination will be nearby. Maximum voltage across the series combination will be nearby. So here maximum voltage across capacitance is 2.5 volts given. So input maximum is asked. Input maximum. So what is capacitive reactance? Minus J by omega C. Find out. Then current is nothing but VCM. What is the maximum voltage? 2.5 by capacitive reactance. 19.63 amps. That is the maximum current. What is VR? 19.63 into 10 ohms. So VR. And applied voltage V is nothing but vector addition of VR and VC. VR and VC. Square root of this square plus this square. So 196.3. What is the logic used here? Maximum voltage given, capacitive reactance find out. To find the current, current into resistance is VR. VR plus VC is equal to V. But don't add it directly, vector addition. That's all. There's another simple power application, calculation of power. See, because of gate problems, clearly problem will not be in one topic. Problem is concept of mixed. That's why teacher is in confusion whether to solve this problem in which topic. So sometimes it happens. Now RLC given, L is 1 by 20, C is 1 by 60, R is 1. Then I of t also given. Find average power dissipated in resistor. Average power. So it's a resonant topic. And what is the resonant frequency? 1 by root LC. Resonant frequency is 1 by root LC. 1 by root LC simplify. This resonant frequency not equal to 120 pi. What is input signal? I of t frequency 120 pi. What is resonant frequency coming is this much. So they are not equal. Means what? Circuit is not under resonance. Circuit is not under resonance. So using steady state analysis approach, find inductive reactance 6J, capacitive reactance minus 0.5 J, then use nodal analysis. Use nodal analysis. So using nodal, this current equal to this current, this current, this current. So incoming current equal to sum of the currents leaving. Solve for V, then power is nothing but V square by R. Right. So this analysis carefully you have to do. Here we are finding V, use V square by R. If it is under resonant condition, this current total will go through resistor. That concept you study in resonance. Then current is known, I square R is power. But here they are not equal. That's why it takes more time to do it. An inductance of 0.5 Henry and 90 ohm resistance is connected in parallel with a 20 microfarad capacitor. The voltage of 230 volts 50 Hz is maintained across the circuit. The total power taken from the source is nearly total power taken from the source. So once again, this total power is nothing but voltage into current. So find this current and this current. For that you need inductive reactance. So J omega L. Find out inductive reactance, capacitive reactance. I equal to V by Z. V by Z. So small thing. Power supplied by the source. Whatever power is supplied by the source, where is dissipating in the resistor? So it is equivalent to find the power dissipated in the resistor. That is I square into 90. 1.27 square into 90 is 145. The power supplied by source also will be same. If you got a doubt, what you can do, find this current I, find this current I, add these two, then this voltage and current multiply, take the real part, that is also same. So this is a little bit logically can solve. So last problem. Yes, star to delta application. The circuit shown V of t 2 sine 1000 t given, RC value given, resistor and capacitor. The steady state current I of t in milliampere is. So outside is delta, inside is star. Resistor is in delta, capacitor is in star. So these capacitors change into, you know, this formula na, Ry equal to R delta by 3, Cy equal to 3C delta. So delta equal to Cy by 3, C by 3. Then capacitive reactance minus J by omega given, C value given. So minus 3000 J. Now after this star, change it to delta. This capacitor will come like this. And this capacitor both are in parallel. So R value of R is given 1K, capacitor reactance minus 3000 J. And this and this is in series. So circuit looks like this. Z, again Z plus Z. Z plus Z is 2Z. So Z equivalent is Z parallel with 2Z, 2 by 3Z. Okay. But Z is what? After simplifying, whatever you are getting, that value. So 1 by Z equivalent is 3 by 2Z. 3 by 2. Z value replace. Then compare. R equivalent is 2R by 3, C equivalent is C by 2. But what is the question is asking? The steady state current V of this current is asking voltage given. So current is nothing but voltage by impedance. Okay, or see, there are two ways of doing. Total impedance, fine. Current is nothing but voltage by total impedance. Straight away you can do. Or here he has done in a different way. This current plus this current. This is nothing but this plus this. So this current is nothing but voltage by Z. This current is nothing but voltage by 2Z. Like that also you can do it. Okay. So this is the answer. You can solve the problem so many ways. So these are all collection of good problems. So each problem, note down the problem, then solve yourself. Write the notes neatly so that whenever you want to read the notes, the hard copy is available with you. You can review easily whenever you want. So I am closing this topic. Topic is over. Steady state analysis over. Next topic is construction of power triangle. Thank you.